problem number 11. And in part A, it gives that f of x is equal to x plus 2 over 2x plus 1, and g of x is equal to x over x minus 2. It wants us to find f of g of 5. So there's a couple ways that we could do that. We could first just find what f of g of x is, and that's probably what I'm going to do. So what that means is that anywhere in our x, or in our f of x equation, we see an x, we're going to plug in our whole g of x equation. So that will give me x over x minus 2 plus 2 over 2 times x over x minus 2 plus 1. And now we're just going to have to plug in 5 for those x values. Gives me 5/3 plus 2 over, this will be 5/3 times 2 is 10/3 plus 1. So on the top, this is 6 over 3 plus 5 is 11/3. And this is 10 over 3 plus 3 over 3, so that's 13/3. Multiply the top by 3 over 13. And that will give us just 11/13. So that's for the first part. You could have also found what g of 5 was. And g of 5 would be 5 over 5 minus 2, which is 5/3. And anytime you saw an x in the f of x equation, you could have just plugged that in. So either way, it works out. The second part gives us two different equations. It says, given that f of x is equal to 1 over x squared, and g of x is equal to the square root of 1 minus x, we want to find f of g of x. Again, a composite function. So this would just be 1 over square root of 1 minus x quantity squared. But it also wants the domain for this. So before I square it out and cancel out the square root, I'm going to find the domain. Because remember, going back to composite functions and domains, you have to take the domain of the original and see where they overlap. So the domain of this, we know that our denominator can't be 0, and we also can't take the square root of a negative. So I want these values, my x values, to be negative. So I want them to go from negative infinity up until 1. So I can have 0 there because 0 plugged in is fine. The only value I can't have is 1 or anything greater than 1, because remember, I want the inside to be greater than 0. So yeah, so this is how the domain for that function looks. And then you could also rewrite it as 1 over 1 minus x. And then for f of g of x, that would be equal to 1 over x squared over the square root of 1 minus x. So which is equivalent to 1 over x squared square root of 1 minus x. And the domain for this function, we know that x cannot be 0, and then, so we know the domain for this already, this 1 minus x. We know that that's from negative infinity to 1. But for this x squared here, we're going to have to exclude 0 as well, because our denominator can't be 0. So this is going to go from negative infinity to 0, union with 0 to 1. And again, it's a parentheses because we can't let it equal. And that is how you do problem number 11. Oh wait, and there's one last part. It wants us you to find f of g of 0. So here, we're going to plug in 0, you get 1 over 1. So f of g of 0 is equal to 1. And that is problem number 11.